Good morning to one and all. Myself, I am Dr. Satish Reddy. Today, you are going to start the course 22 BM 304 Biomechanics. So, the main the objectives, the syllabus has been framed into two modules, and each module contains of the two units framed based on keeping the four objectives into the mind, and the first two objectives will cover the first module and the last two objectives will cover the last modules. The first one is dealing with the basic engineering principles of the mechanics and how these engineering principles of the mechanics will be used to solve the biomechanical problems or case studies. And the second one, we are going to talk about the mechanical properties and behavior of the biological tissues under the different conditions, just like how the stress has been developed and strain will affect the biological tissues, or sometimes it may be ruptured during the accident cases. That cases we are going to study all these things. And the third one, you are going to talk about the human movement analysis and how the impact on mechanical impact on the joints, and learn about energy and power aspects for a particular movement. And the final one, we are going to some little bit advanced technique. We are talking about the design aspects and what are the basic background is needed to learn the design aspects of the biomechanics, and it is more helpful in medical field to design the prosthetic and orthotic hands. The next, after completing this course, the student can able to do the outcomes is defined as the first one is that apply mechanical forces to the joints to derive the basic equations for a solid and liquid bioelements, and the second next is that analyze the properties of structures and functions to human joints for normal and diseased conditions, and third one is derive the equations of fluids for estimating the pressure in vessel, and the fourth one analyze the statics and dynamic patterns, and the last one is that the properties of the forces estimating on the human joints, which helps designing the exoskeleton devices. Here the exoskeleton devices is basically robots. These things will help the humans to reduce their efforts. You are getting the maximum output at the lesser efforts. That we will discuss separately about the exoskeleton devices. So these are the courses outputs, and the reference books, textbooks and reference books here. Nihat Ojkaya main textbook for this course, and the second textbook is R.S. Kurmi, a textbook of engineering mechanics. This is the basic textbook which deals with only the principles of the mechanics only. And the first one, you are going to get the information regarding the biomechanics perspective, and the remaining three are the references books. We are going to refer a particular concept from these books. Mercillo Epstein, the elements of continuum biomechanics is one book, and Pamela Leverage, the joint structure and function, a comprehensive analysis, and J.D. Humphrey, an introduction to biomechanics. These are the three reference books. And the next one is a few important web resources. We can help it. This is a global web resource I kept here. The first one is that International Society of the Biomechanics. The link is given here, and these things will help the students. For example, you are all third year students. For example, you are selecting your specialization to work ahead with the biomechanics course, and it's continue the specialization in the biomechanics. In such cases, these are much helpful for you. And the next one is that Biomechanics World is another website, and the last one is the OpenSim software. It is an open software framed by the Stanford University. This is very helpful for the students to learn or design a model to stimulate the human movements. So the first unit, the outline of the entire unit is given as 6 steps. The first one is that the principles of mechanics and vector mechanics. So the principle of mechanics, you are going to talk about the forces and result of that particular force and then acceleration. And the next one is that vector mechanics means that vectors is a mathematical tool. You are going to solve that mechanics. That and all you are going to talk in the first one, and how these vector mechanics has been correlated to the biomechanics. And the second one is the mechanics of motion and Newton's laws of motion. This is also basic principle only. maybe you gone through in +2 standard also, but we will go in depth of analysis. And the third one is most important thing is that the kinetics and the kinematic motions. Here the kinematics is nothing but in kinematics we are going to speak about the forces, and due to that one what kind of output you are going to get. That means that what is the acceleration you are going to get and what is the displacement. All these three parameters we are going to speak. And whereas the kinetics, these are the deals with what is the cause for the kinematics and what are the forces which cause the kinematics, that we are going to discuss. And the fourth one is that biofluid mechanics, Euler equation, and fifth one is that viscoelasticity and constitutive equations, and the last topic is stress transformations and strain energy functions. So let's go through one by one topic. The first one is talking about the principle of mechanics and vector mechanics. So what is meant by mechanics? We are going to speak in the mechanics is a branch of physics dealing with the forces and motion of the bodies, which includes the three subparts. The first one is the statistics. So we are going to say that the statistics, the body is at rest, study of the body is at rest in equilibrium. Even though it is in the rest, some forces is acting on that body. That kind of forces we are going to speak. And the dynamics is nothing but we are going to study about the bodies which are in the motion. And the third one is second one is the vector mechanics. Means that here the mechanics and statistics is the subpart of the statistics, and dynamics are the subpart of the mechanics. And the next one is the vector mechanics is nothing but we are using the vector as a mathematical tool to represent the forces, velocities, accelerations and displacement. So these vectors makes easier to analyze the directions and the magnitude of these quantities. So after combination of this one, we are going to speak about the term, it is called as a biomechanics. Now we can merge the both things, the mechanics plus biological aspects. So applies the mechanical principle to the biological aspect, especially in the human body. The next one is the Newton's laws of motion. So there are three laws are there. The first law, it is going to deal with the law of inertia. It states that the body remains in the same state. That means the body either it is in motion or it may be in the rest unless acting upon by an external force. For example, you are going to say that you take a body with respect to point A, this is the point A, body name as A, and this is the point B. An object is here, you can say that it is an object. If you want to bring this object from A to B, definitely you must apply or some that is either internal force or external force must be applied onto the object to create the movement so that it can be reached to the B. Unless until if we are not applying any kind of the force to on the one, it will be remains in the same position, and we can say that that is equilibrium condition also, that will come in the later stage, that we will discuss equilibrium conditions. That is called as the first law of inertia. And second law of inertia, we are going to say this is called as the acceleration law. We are going to say that the acceleration of the body is proportional to the net force acting on it and inversely proportional to its mass. So F is equal to ma. In general, according to this, we can going to say that the total, we are going to say that the total A is directly proportional to the net force acting on the body. A is equal to F. So how we are going to get the second one? You split this equation, F is equal to ma and A is equal to F divided by m. In such cases, we are going to again split the same equation, F into 1 by m. Here you can split it. A is directly proportional to F and A is inversely proportional to its mass. So that's what it is going to say, that the law of acceleration. And the third one, very well known equation to all, this is the third law. It is called as a, for an every reaction there must be an equal and opposite reaction. Most probably you are going to talk about the forces. For example, if you are throwing a ball to the wall, so how much force you are applying, and the same kind of force applied by the wall to the ball, so that we are getting the ball reflected and you are going to catch that. And you are going to say the another condition, I already discussed about that, equilibrium conditions. So for statistics, the sum of the forces and movements acting on a body must be equivalent to 0. So what does it mean? That whenever you are going to say any body is in the rest, for example, this is the body, you are going to take it, and almost all the forces will be going to emanate in its structure. So in order to keep this body in static position or statistically at rest, the forces, the sum of the forces acting on a particular body must be equivalent to 0. That we are going to say that the F bar must be equivalent to 0. So why I am using that F bar, arrow mark indicates it is in a vector quantity. So due to whenever the force is equal to 0, ultimately the momentum also is going to 0. The next one is that vector mechanics. So, the vector mechanics involving this is nothing but we are utilizing the mathematical tools available in the vectors quantities which both magnitude and direction to solve the problems related to the forces and motion. This is crucial why, because sometimes the forces are having the both magnitude and directions, and motion happens in the 3-dimensional places. And the next one is that vector operations. So, these are well known that we are using the mathematical tools to addition, subtraction and dot product and cross product. We are studied in your 12th level itself. Now, in our course we are not going to study again the basic mathematical operations and all. So, how you are utilizing these kind of operations to solve our particular problem, that we are going to discuss throughout the course. So, how these things are connected each other, the forces and motion in the human movement involves in the forces generated by the muscles and gravity, ground reaction forces and other factors will be there, and the vector mechanics helps to describe the forces and the directions, magnitudes and points of applications. So, what is the statistics in biomechanics? So, now coming to the statistics part. So, the first part we are going to talking about the postural stability. So, postural stability, the body of the body segments can be analyzed as a rigid bodies, and as we discussed earlier, at the rest in the static equilibrium, example standing posture, or we are going to sit, or we are going to bend to maintain one particular position. Posture is nothing but the position what we are maintaining in that particular point and the particular time period. The net forces acting on the body should be equivalent to 0. So, for example, we are going to say that the ground reaction forces counters the body weight and muscle forces stabilize the joints. So, where we are going to get the joint forces? The joint forces we are going to generated between the two bones in the body. So, the joint reaction forces calculates using the free body diagrams and vector mechanics. By utilizing the applications of the free body diagram and vector mechanics, we can able to calculate the joint reaction forces. And the next one is that and these calculations in practically where we are going to use. This is the application part oriented for accident persons or for any empty persons. We want to fix any kind of leg or any kind of things, leg or hand, what are the things we are going to design, and each and every person having his unique features. So, the kind of unique features you have to design by yourself, and you can utilize that one to get the output like a design kind of prosthetic design and other things. And here the concept of ergonomics is also coming into the picture. Ergonomics is a total different story and different subject where it deals with the total design aspects and comfortness of the patient. So far we discussed about the statistics parts involved in the biomechanics, and another one is that human motion, and everybody knows that motion in the sense that it is nothing but walking, running, jumping, and where simply you can say that where you can able to generate the acceleration of the body segments, and the Newton's second law is applied to analyze such kind of cases. And the next one is that inverse dynamics. So, inverse dynamics, it starts with the measure of the motion kinematics and external forces. You have to measure that. We are going to utilize the vector mechanics and Newton's laws of motion. For example, this is one of the case study to calculate the knee joint torque during the running from a motion capture and a force bit from data. We are going to say that the motion capture and the force place data nothing but these two things we are going to get from. So, very important thing, these two things we are going to get from the called gate lab. So, in the gate lab we are going to do this kind of activities that in detail we will see in upcoming classes. For your understanding purpose only I told this. The next is that the forward dynamics. In this part we are going to talk about given muscle forces and predict the motions, and these kind of things it is used to simulation to study gait, sports performance and rehabilitation purpose we are going to use. And the next is the movements and torque. So, what is meant by torque? It is a well-known definition will be there that muscles produce the forces that create the movements about the particular joints. For example, for your understanding purpose, you can example you are going to say that if you want to lift or if you want to open a door, so where you are going to use your things, and this is the particular point, common point where it is rotating. So, where you are going to apply your force, this is maybe point we are going to say force. So, in such cases, what is this? Force arm length. And next this vector mechanics allows the decomposition of muscle force vectors and calculation of the effective torque and movement arms perpendicular to the line of the muscle force joint, and finally the movement you are going to get is equal to the M is equal to this force, what is the force you applied and multiplied with the distance F into D. The distance means the fixed point where the object is being rotated to the force, the point where you are going to apply the force. So that is the distance. M is equal to F into D. Moment and F is the muscle force. D is the moment arm length. This is the moment arm length. So energy and work, the work done by the muscles equal to the force times displacement direction force, and power output relates the rate of work, and energy principles help to analyze the efficiency and fatigue, and mechanical properties of the biological tissues. Biomechanics another concept in the mechanical is that so far what we discussed the solids and what are the mechanical principles we are using. Now we are coming into the soft tissues kind of things like muscles, tendons, ligaments and bones. And another is that in this case we are going to talk about the stress and the strain, where the vector or tensor quantities describing about the internal forces and deformations, and mechanical principles we are going to use to find out injury thresholds and material properties and adaptation. So mathematical modeling, what are the importance of the mathematical tools? So biomechanical models, it is built based on the mathematical tools only. So biomechanical models will help to use the vector mechanics to simulate the human movement, and rigid body dynamics, multi-body systems and finite element models. So these are the rigid body dynamics, these are the various tools, and multi-body systems and finite element method. These are the different methods, mathematical tools we already have to design biomechanical systems and predict the force, and by using these methods we can easily predict the force, movements and stresses during the activities and particular treatments. So totally in summary, so what we studied so far, we are going to talk about what are the mechanical principles and what is the vector mechanical concepts and what is the applications of that. So starting from the definition of the mechanics and definition of the vector forces and its applications, after that we are going to talk about the Newton's laws. The Newton's laws deals with the force vectors and acceleration movements, and its application is that vectors and tensile field winds and static equilibrium when the object is at rest. What is the condition you are going to take? Mathematically it is very important to remember summation of F and summation of M must be equal to 0. So where you are going to utilize this application, the posture analysis and joint stability. Dynamics is a vector kinematics and kinetics, and very important point is that in laboratory aspects the gait analysis, sports biomechanics we are going to do. Gait analysis is nothing but by using this we are going to analyze the positions, and it is much helpful for you to utilize in sports biomechanics. Your suggestions may be helpful for the athletics to get the best performance. And the movements, torque, so this is the definition of the movement. Instead of D you are utilizing the R here, that is radius. Next one is that measure torque about the joints. To analyze the joints we are going to utilize this formula, any kind of the joints. And work energy power, scalars derived from the vector forces. So where we are going to using this concept of work energy power means you are going to find out the muscle efficiency and fatigue analysis. And the last one is that stress and strain. So these are the two things we are going to utilize to study about the tissue biomechanics and injury biomechanics. So coming to the next point, the kinematics and the kinetics. As we already definition I already told you, the field of kinematics is concerned with the description of geometric and time dependent aspects of the motion without dealing with the forces causing the motion. So this is based on the relationship between the displacement, velocity and acceleration. So displacement means the distance, the letter we are going to use the D, and the velocity we are going to use LSD. Again we are going to say that maybe two quantities will be there. The first letter we are going to say that U may be initial velocity. Most of the static biomechanics, the initial velocity always is equal to 0, but if we are considering any object which is in the motion, that may not be 0, and we are going to say another letter, nomenclature here, the V is equal to final velocity, and the acceleration is equal to the letter A, and we are going to identify always the different relation between these four variables in the form of the different and integral equations. And the last term it is called as the kinetics, nothing but it is based on the kinematics only. So what are the forces caused by the kinematics parameters? That's what we are going to study in the kinematics. So kinetic analysis utilizes the second law, and the mathematical approaches are based on the equations of motion, work, energy methods and impulse momentum methods. Different methods may be applicable for different situations. Means as already told you, no one having the unique features in biomechanics. So definitely you must do calculation for each and every case, for each and every person, and it vary from one field to another field. For example, one sports to the another sports. And the final one is that the kinesiology, it is a study of the human motion characters, joints and muscle forces and neurological and other factors that may be implemented in studying the human motion. The term kinesiology is not a mechanical but it is a medical term. So don't confuse over here. We have discussed about the three three terms we discussed so far. The first term is that the kinematics, and the second term is the kinetics, and third term is the kinesiology. So the kinesiology, study of the human motion characteristics, joint and muscle forces. The combination of both you are going to study, but in case of the kinetics, what are the forces cause the kinematic, that only you are going to, we studied that. So what are the different kind of the motions? Different kind of the motions, there are three terms will be there. The first one is that translational and a linear motion, and a rotational and angular motion, and the combination of both. These are the different kind of the things. Well known that is the translation by linear motion, causes the all parts of the body move in the same distance, the same time, and the same direction. So maybe this is a one kind of the movement A to B, and another is this kind of movement A to B, another is any kind of the movement A to B. So these are the three different cases. Like that we can visualize where our definition will be going to fit to our movement. All the parts of the body should be moved in the same time and the same distance. So that's what it is called as a translational and a linear motion. The next one is that rotational and angular motion. Whenever moves in a circular path, that means that whenever the body is going to move either in circular motion or you are going to say that semicircular motion, this kind of movement, fixed movement, this is called as a semicircular motion, or you are going to say that this kind of movement, you are going to say maybe flexion, extension, any kind of elbow or kind of any leg, that we will see in detail later. Just for our understanding purpose I draw this, that is a rotational and angular movement. So general motion which occurs the body undergoes the translational and rotational. It is a complex things going to happen. So we want to analyze, analysis of the linear is quite easy when compared to the rotational, but whenever you are going to analyze any kind of the movement, it is maybe combination of that, so it will make some complexity will be there, and we need more mathematical tools to incorporate with that. So far, thank you. We will continue in the next class.